Howdy, this is your friendly neighborhood physics teacher here, and I had a couple of questions over the friction problem, so I'm going to do one as an example real quick. So you have a box, you had a force gravity on the box, and let's say the force of gravity on the box is 10 newtons. We have a force of normal because the box is sitting on the table, and we're going to say that force of normal is, guess what, 10 newtons. Oops, I can sit there and 10 newtons. The box is sliding across the ground, so we're going to say we have a force of friction, but we don't know what that is. And we're going to change it up a little bit, and I'm going to give you the acceleration. We're going to say the acceleration is 5 meters per second squared to the left. Or I could have written it -5 meters per second squared. So, could have done it either way. And then I want you to find what you're looking for is obviously your force of friction, and I also want you to find your coefficient of friction. Now, it is accelerating, so specifically this would be your coefficient of kinetic friction. So kind of like your little setup there. The first thing I would do is try to find your mass, because we need your mass. So we know gravity has its special little equation there. So force of gravity equals your mass times the acceleration due to gravity, which in the problem I told you that we're going to round the g to 10, and if it's -10 meters per second squared. I told you that in most of your problems there. So force of gravity is pointing down, so that becomes a -10 equals m times -10. We're going to divide both sides by 10. And we get that the mass equals 1 kilogram. We have mass, we have acceleration. So we can figure out the net force in the x direction. Do we need to worry about the net force in the y direction? It's balanced, it's zero. What we need is in the x direction, so we don't even have to worry about the y direction. We know that the sum of the forces is just mass times acceleration. What forces are acting in the x direction? Well, we only have one, and it's friction. And it is negative. Oops, make it color coordinated. So it's going to be a negative friction equals, we know mass, and we know our acceleration. This should be our acceleration in the x. Oops. So left, right shouldn't have specified, but acceleration in the x. So now we just plug in what we got. We are looking for force of friction, so we don't know that. We know our mass, which is 1, times our acceleration, which we know is -5. So we can go ahead and get the negative over here. It cancels out that negative, so we have force of friction equals, and then 1 times anything is, so force of friction equals 5 newtons. So now we know that our force of friction is 5 newtons. Now that we know our force of friction, we know our force of friction has a special equation. Our force of friction is mu times normal force. So our force of friction is 5. We're looking for our mu, and our normal force is 10. And it's positive because it's going up. We need me by itself. So we're just going to divide. And I'm sorry. Now remember, I do it naturally, but your force of friction and force of normal has those absolute signs in there. So yes, technically it is a negative, but that absolute sign takes away that negative away. So because there is no unit, your coefficient of friction is a scalar, so there is no direction. So it's kind of trying to cancel everything out. So in this case, you get 5 over 10. 5 divided by 10, which you get 0.5 equals mu. So there's your force of friction. There's your coefficient of friction. I did not use numbers. I don't think I used numbers off the homework, so this isn't an exact replica of the homework, but it should kind of tell you the steps you need to do. Hope that helped. Remember, you're loved and appreciated. Bye.